We're going to take a look at proper use of the plasma cutter here in the Tyler Metal Shop. This is for cutting steel, stainless steel, aluminum, copper, whatever you want with this one. It'll cut through it if it's metal. It does have some restrictions, obviously, in terms of material thickness, but we'll get into that in a little bit. So first thing to think about is we have a lot of very useful information up on this wall chart here above the machine. And it will give you a lot of useful information. So if we take a look in here, you've got your basic operations and the front panel and what those different lights and buttons are. Basic torch assembly, so in case you need to replace any consumables, you've got a little exploded view and descriptions of all that. This is a really useful chart for understanding how the machine works, for getting decent cuts and troubleshooting. And if you take a look at this graph, you've got speed of travel when you're cutting along here, and then this is the material thickness, so how thick the part is that you're cutting through. And notice that the thinner your part on that end, the faster your travel speed, and then as we get to say around 1/4 inch, it starts to drop off in terms of effectiveness, in terms of how slow you have to go to sever through things. And so I really wouldn't even bother working on anything any thicker than 1/4 inch on this machine. You might be able to lop off some parts around 3/8 or thicker, but you're not going to get a really good result, and you're going to have to move real slow. Over here we've got some basic operations, so step by step on cutting, really helpful if you're just trying to gouge something, you know, just for an effect, or to have an area where you can kind of lay a weld into, that's there. And then piercing is sort of a combination of the cutting and gouging, and it gives you a little step-by-step on that. So all those are really helpful to look at. And then also down here you've got a basic troubleshooting. You can read all the descriptions over here, what those different numbers are, but basically number 1 is your amperage is too low. Number 2 is your amperage is still too low, but you're just traveling really, really slow. Number 3 is your amperage is too high, so you get a big wide kerf, but it works. And then number 4 is a good cut, right? Reasonably thin kerf, not a whole lot of burn through. And number 5 is where your consumables are a little worn out. And if your consumables are really worn out, you'll see that it doesn't even strike up at all, it doesn't cut at all. So that's when you want to go and talk to the technician. So that's the chart there, basic understanding. Then over here we've got your safety chart, which is required for personal protection equipment. So we're going to need they're saying a welding mask. You need a shade 5 welding mask. Make sure you're wearing all the same sort of gear you'd be working with if you are welding, in terms of other outer clothing, leathers, light cotton shirt, you know, long pants, no cuffs or things that sparks can get caught into. You got to wear gloves, wear good shoes or shoe protectors. So a good pair of leather work boots is ideal. Avoid anything with an open toe. And then you may want to wear some hearing protection. It does get a bit loud in here. And then the breathing protection, respiratory protection. We recommend you wear a welding respirator for this one. If you have any kind of health issues, you want to get checked out to make sure that you can breathe safely through a respirator, but you definitely want to use one of the fume extraction units hanging above the table there. So getting this thing fired up, and I'll show you how to turn that fume extractor on and the machine itself. Before we ever even go flipping on the on switch here, we want to turn the air on and prepare the machine. So you can see we don't have any pressure reading there. So what we do is we follow that little blue hose coming out of the back of the machine, and we find ourselves at the regulator over here. And typically this regulator is only used for the plasma cutter. So what we do is we just ease this valve open until it's parallel with the pipe. Any of these ball valves, when they're parallel with the pipe, they're open. Perpendicular, closed. And then we can see here that we've got about 80 psi on there, which is fine. We just want this set a little higher than what's set over at the machine. And again, typically nobody needs to mess with these valves, but if it's giving you issues, you'll just want to check that you have the right pressure. While we're over here, you can see we've got a safety feature with fire extinguishers there. Obviously follow all kinds of metal shop procedures in terms of keeping flammable stuff away. And then here we've got the snorkel fume extraction units. We've flip that switch up there when we're going to work. For the purposes of this video, to keep the audio levels good, I'll keep it off, but you're always going to want to have that on when you're making real cuts. And so keep that on when you're working. Now, coming back over to the machine, if you flip the on switch and nothing happens, well, check and make sure that it is plugged into the wall. We share a plug with the stick welder, which is underneath it, so don't get the two machines confused. The plasma cutter is on top, and its leads are on the right-hand side, and for the stick welder, they're coiled up on the other side. So make sure you're grabbing the right leads. You could always just trace them off the machine here to make sure that they're going where they need to go. So make sure you're plugged in. And then on the front of the machine here, we'll fire this up. So with the air pressure on, and we're a little higher than between those two lines, but operating pressure is probably a little lower. We'll flip the on switch, and then the machine just does a little boot up, and right now it gives you the green light. You're good to go. If for some reason we had like not enough air pressure, if we didn't turn that air on, so I'll do that by removing the air hose in the back, you can see that we get a dummy light for the air pressure. Or if the torch wasn't assembled properly, we'd get a dummy light for that, and then it'll check itself out. If for some reason after you correct the problem it doesn't come back to a green light, then just cycle the machine off and then back on, and it should be good. If you get this over temperature light, it means you've been cutting a whole lot of material and the machine needs some time to cool off. So just let that machine cool off, leave it on, let the fan run, and then when that temperature light goes away and you're back to green, then you can keep cutting and maybe slow down a little bit, give the machine some time to catch up. Amperage. So most things people are cutting, you can kind of keep it a little on the lower side, around 30, between 30 and 35 is generally what people are doing. If you're cutting real thin stuff, you can lower it down even more, but this is sort of a, if it's working, you generally want that as low as you can stand while still getting a decent cut. If you have it always cranked up, you're just going to wear out the consumables a lot faster. So for our purposes, we're cutting through about 1/8 inch plate. I'll keep it around 30, and if I feel like I need more, I can turn it up or turn it down, depending on my cut. Let's take a look at the ground clamp here and your torch lead. So first, the ground clamp gets hooked up to the part that you're cutting. In this case, I'm set up over on the cutting table, also really important to set up on the cutting table. And generally speaking, you hook up that ground clamp to the as close to the cut as is feasible. So if I'm going to use this straight edge as a guide, I'll keep that ground clamp pretty close to where I'll be cutting, and I'll get better results. And then over here, we'll grab the torch lead. Notice it's got this leather protector on it, and you don't want to kink this line. Always just let it sort of drape down to the floor relatively naturally and untwist it as needed, and you'll be in okay shape. So I don't need a whole lot of cable to get to where I'm going at the moment, but just make sure it's not underfoot, and I'll get ourselves a better view angle of what we're going to be doing here. So notice that we're working on the cutting table here, and that's very important. You don't want to be cutting on one of the welding tables, because then you're going to put all these gouges or cuts into the welding table. So we always use this table. If you're cutting a really large part, you can always prop it up with some bricks and do it on the ground. But you need a little bit of space underneath the part that you're cutting in order for that material that's getting ejected to have somewhere to go. So we don't want to cut it directly on a floor surface. We don't want to cut it directly onto a table, because things could get dicey. And you'll get all that slag and sparks shoot back up at you, and that's not safe. So I'm working with about 1/8 inch plate here, and if I want a nice straight cut, I'll use a straight edge in order to guide the torch. And another good rule of thumb is I'll pull it towards myself, and if I have all kinds of rough or bumpy stuff on here, the torch is going to get hung up, and we don't want to do that. You can drag the torch. We have one of these drag tips on here. It's got little crosshairs to allow the material to kind of eject on the sides when piercing or towards the edges. And generally speaking, we move in a direction that will that we have the most control over. If you try and push it along, you're not going to get a good result. You can also do, freehand work or draw a line on there with some soapstone, and do that, and you can get all kinds of funny shapes with this. Here's some of the safety gear that we're talking about. So the face shield that we need is one of these Shade 5 face shields. You can actually see through them in normal light. They're just dim. They don't work for welding applications, for electric welding applications, but this is what you're going to want when you're using the plasma cutter, and it offers you full face protection, so that's a really good option. If you want, you can also wear the Shade 5 goggles, but then wear a clear face shield over that if one of these isn't available. So this is a good option for that. And this is also in addition to safety glasses, okay? So you want to wear safety glasses and a face shield, Shade 5 face shield, because when you're hammering on things and those sparks are flying around, they can get all over the place. Breathing protection, here's one of our more recommended ones. You can kind of pick these up, and they have different styles now, but you want to make sure that the cartridges are rated for this sort of work. Ask the technician to understand what cartridges you'll need to be working in the welding shop, and notice that these are low-profile ones made for welding, and they'll protect you from some of the fumes and the dust. You're basically vaporizing metal in this application, so we're going to want to make sure that you're protecting your breathing. Got a light pair of gloves here, and you can also wear some hearing protection of your choice. Earplugs or over-the-ear protection will be fine, because you might be banging around on stuff too. So let me get this face shield on for the time being, and after that we'll get our gloves on. One other little tip in terms of getting your parts to, if you have a bunch of funny shapes that you want to cut out, here's a good little tip for you. So let's say you have your favorite drawing of a kitten that you want to render in steel. And what you do here is basically transfer that drawing of a kitten to a piece of masonite. This is a dense but very thin piece of wood, and it will wear out. You don't want to aim the fire directly at this thing, but notice how it's sort of a little smaller than the kitten. That is to account for the distance between the cutting surface here and then the center, or where the kerf is going to be. And so I just made that line, fought along at that distance, and wound up with this template, which I cut out and fine-tuned over in the wood shop. And then you clamp this down to the material that you're going to be cutting, and you trace along the edge of this, and what you wind up with is a metal blank that is now pretty darn close to the drawing that you had before. Obviously still some grinding and cleanup to do here, and then maybe some filling in of your other features, but you get the idea. So transferred over fairly accurately. So templates are really great, and straight edges are really great. That will really improve your plasma skills if it's something that you're trying to do, and make look good. So we'll set these guys aside for now. And another thing too, if you're just kind of cutting out and freehanding stuff, having a chipping hammer is really handy for just knocking some of the parts off or the slag off. You'll see that in a moment. I'll fire this up and make a quick cut or two. So we'll get these light gloves on. We'd normally have that snorkel going, and maybe we will throw it on just to make our lives a little. So here we have our system, and I'm sure hopefully you can still hear me all right, and we'll make a quick plasma cut on our part here. So first I'll just show you how this trigger works. You lift up on this little safety, and then you pull back on the red trigger, and you want to be, if you're just doing cutting, you'll want to start basically just off the edge of your material, and then you can make your cut and then pierce through. Now if you're trying to do a center cut somewhere, maybe we'll do this on the other surface here, and then we'll cut our other part off. Throw that clamp on here. So if you're going to do an edge cut, we'll do one of these. So you can see that part just dropped right out, and then we could easily knock that piece out if it didn't go all the way. If you went too fast, you may not have cut that all the way through. Now, if you want to do a pierced hole, let's say, start somewhere on the interior of that hole, hit the trigger, and then ease in, and then you can come back around, and most of that's cut through. We can knock it out like so, and there's how you do a pierced hole. It's not going to work on super thick material though. Now, if we were trying to do that straight edge cut, we'll throw our ground clamp on here. The part's probably going to drop off, but I'm basically just going to offset this so that I can ride my torch along it. And if you are moving too slowly, you'll get a little bit more slag, and if you're moving too quickly, you won't be cutting all the way through your part. And you'll notice if the air keeps coming out here, that's just cooling off the torch. That's normal, and it'll turn itself off in a moment or two. So there it is, turning itself off. Now let's take a look at the back side of our cut here. Now, you almost always wind up with a little bit of slag on the back edge of your cut, and most folks sit there with a grinder or a file for a while trying to get rid of all that material, but a really great trick is to grab a chisel or one of these chipping hammers with a fairly decent edge on it, and you'll see that you can usually, with a glancing blow, knock off the vast majority of that material. So that'll save you a ton of abrasives and a ton of time to use that little trick. But that is the basic gist of the plasma cutter over in the Tyler Metal Shop. Always make sure that when you're done, you clean up after yourself and coil up those cables properly. If you have any questions, always just ask your instructor or ask the shop technician, and please wear your safety gear and be nice to the equipment. Don't use the torch as a hammer, that's the hammer, and using guides will really increase your skill level and the level at which you're able to achieve with this machine. So work safe, and good luck.